This is a demo of the liquid limit test, a standard engineering test for clayey soils. We start with a sample of the fine-grained material at a water content a little bit below the liquid limit. So the consistency below the liquid limit should have the texture approximately like peanut butter. So this is a little bit drier than the liquid limit. So we expect it should take more than 25 blows to close the gap on this material. So you can see the lab tech Eric spreading the material into the Casa Grande cup here, making sure it has a relatively smooth upper surface. So just smoothing the material down until it has a reasonably flat upper surface. And now we use a standard scoring tool, which has a standard width and depth to make the gap in the material. Now as you turn the crank, if you watch on the left hand side, there's a counter that's increasing the number of blows. Each blow of the Casa Grande cup is a standard height, so you can see the cup raising up and lowering each time it's putting the same amount of energy into the material. So we can use the blow count as an analog for the amount of energy required to close the gap. So we're continuing to turn the crank until the gap in the soil closes by a few millimeters. Okay, so you can see this material achieved a blow count of 31 as the gap closed. After each test, we'll take a small sample from the material and put it into a cup, and we'll weigh this immediately on a scale that's sensitive to the 100th of a gram, so to the centigram. So we're taking a nice sample of the material here. Since that sample was a bit drier than the liquid limit, now we'll increase the water content a little bit. So spraying a little bit more water into the material, and we'll mix it up as best as possible to spread the water around in the material, and then we'll run the test again. So taking care here to make sure that the material is well mixed so that we get a relatively uniform distribution of water within the material. So after we added some water, we'll be at a higher water content, so we'll expect fewer blows to close the same size gap. Okay, again, we spread the material into the Casa Grande cup. You can see that the material is noticeably wetter, has a slightly smoother texture. When we're above the liquid limit, the texture should look something like texture of yogurt or sour cream. Okay, so again, spreading the material nice and smooth, trying to get the top surface as flat as possible, and then using the standard scoring tool to make the score in the middle of the sample. Again, we start turning the crank, making sure that it was reset to 0 before running this test. And we'll see that this sample, after we added more water, will take fewer blows to close the same gap, so it flows a little more easily. In this case, we get 26 blows. Again, we add some more water to the material. So ideally, we want at least 3 samples with one of them above the liquid limit, so less than 25 blows. One sample below the liquid limit, so more than 25 blows required, and one in the middle, ideally. And then we'll make a line of best fit. So we added a little bit more water to this sample again, and we'll test it again. So this is the wettest of the 3 samples. So we should see the fewest number of blows. And this sample had the gap close in 14 blows. Next, we'll demo the plastic limit test, another standard test for fine-grained soils. We start with a specimen that's quite a bit drier than the liquid limit test. It should have the consistency about that of modeling clay or plasticine. You can see in the frame here a glass plate and a glass rod. The glass rod is a standard diameter and length. The plastic limit test is defined as the water content at which a specimen of the material breaks into several chunks as it is rolled out and reaches the diameter of that standard glass rod. So now you can see the lab tech here, Eric, has a sample of the material and he's rolling it out. As he rolls the material out, he takes a little bit of water out of the material as it's rolling around on the plate. You can see some of the moisture smearing on the plate, and some of it is being sort of rubbed around and evaporated by the rolling motion and through his contact with his fingers. It's difficult to visually estimate sometimes how thick the rolled out sample is. So the key here is to roll the material very close by to the rod, and you'll see sometimes it's easier if you actually roll the rod and the specimen together so you can feel if they're the same diameter or not. If you're able to roll the specimen out and it reaches the same diameter as the glass rod without breaking up into several chunks, just bunch the material back up together again, roll it around in your hand a little bit, and then start the procedure over. Okay, so you can see Eric took the same material, made another ball, and now he's going to roll it out again, trying to get it down to the same diameter as that standard glass rod, and it should break into several chunks just as it reaches the same diameter as the glass rod. Okay, so rolling it out, we can see it's getting close to the diameter of the glass rod. Just rolling it out carefully and smoothly. As you roll it out, just separate any excess chunks off to the side. Make sure when you take samples of the material, don't sample those excess chunks. Okay. You can see that what happened with this material was that before it reached the same diameter as the glass rod, it already broke up into chunks. So this is what happens if the specimen's too dry. So it's important to have a little bit of patience with this test. So if the specimen breaks up into chunks too early, then you need to start over again with a new sample. Okay, so you can see what happens here. Eric rolled it around in his hand again, but now you can see the sample's too dry. It breaks up into several chunks even before it reaches the diameter of the glass rod. So we can't really sample this material. This is already below the plastic limit, so it's too dry. So we'll have to start again with a new sample of material. So starting again with a new sample, a new ball fresh from the same starting material as the previous test. Sometimes doing this test takes a little bit of practice and several attempts, even for experienced geotechnical lab techs. One tip about this test is that if your specimen doesn't break into several chunks by the time it reaches the diameter of the rod, when you make the new sample to start rolling it up again, don't roll it around in your hands too much. If you roll it around in your hands too much in between as you make the fresh ball of material, you may take too much water out, and that's sort of what happened in the previous test. So now you can see Eric's rolling it out, and it gets down close to the diameter of the rod, and it doesn't look like it's breaking up yet. So it's still a little bit above the plastic limit. It's still a little bit too wet. Okay, so we take the material, ball it up again, roll it around in your hand a little bit, but not too much. You don't want to take too much water out in between. Remember that we still have to roll the whole material out to the size of that glass rod. Alrighty, continuing to roll it out, being super patient. It's important to remember with these tests is that even though the procedure and the definition of the size of the rod seems somewhat arbitrary, the fact that we have a standardized procedure means that we can compare results from different tests, and that's why we can use it for classification purposes. So even though the procedure seems a little bit arbitrary, it's important to stick as close as possible to the standard procedure so that you have comparable results to tests on other materials. Okay, so again, that material rolled down to the size of the glass rod before really breaking up into several chunks. So roll it around in your hands a little bit again, and roll it out one more time. Separating off larger chunks off to the side, we'll make sure not to sample that material at the end. You can see it's getting pretty close to the size of the glass rod. And rolling them together side by side will help to see if they're matching up in terms of diameter. So this sample breaks up into 2 or 3 chunks just as it reaches a similar diameter to the rod, rolling them side by side just to confirm they're the same diameter. Okay, so that's about what we want. So we'll sample those 3 chunks because those are the 3 that should be at the plastic limit. With all the plastic limit samples as well as the liquid limit samples, we immediately weigh the wet mass to get the mass of water and soils. We should also record the mass of the cup beforehand. And then after getting the wet mass, we put all the samples in the oven, so we can see 3 liquid limit and 3 plastic limit. We'll wait till tomorrow to get the dry mass.